Hey Algebra 2s, hope your quiz went well. We are on to our next way of solving quadratic equations by using the quadratic formula. So keep in mind what you already know how to do. You already know how to factor, and remember that is where you factor each individual expression and set each one equal to 0. You already know how to take the square root of each side, and you know that includes your positive and your negative root. And you know how to be a spoiled brat and get exactly what you want so that you have this set up for your equation so that then you can take the square root of each side, remembering the plus or minus. These two strategies are very closely related. And it's interesting because we want to talk about how is completing the square different from the other two methods. And this is a really important conversation because completing the square allows us to solve for our irrational roots. And that is because a lot of times what is underneath the radical is going to be not always a perfect square. And we end up sometimes with this radicand as we cannot simplify it. So the quadratic formula is going to help us do all of the messy quadratics that are difficult to do with completing the square. So the quadratic formula steps in where sometimes we have those a values where completing the square is a little bit difficult. All right, so a, b, and c are our coefficients, and our standard form of our quadratic formula is ax squared plus bx plus c is equal to 0. And what we're going to do is plug in our a, b's, and c's exactly where we see them. Our b's are going to come from this coefficient. Our c's are going to come from this constant. And our a's, if we have a leading coefficient on the squared term, make it easier for us to solve for those. Here's some important facts. Our quadratic formula works every time. Even with equations that could have been factored, even with things that might have worked with completing the square, with our quadratic formula, it works every time. So don't laugh too hard, but we can remember the quadratic formula by singing to the tune of Pop Goes the Weasel, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that all over 2a piece becomes really important because we want to make sure that we know that this entire expression, this plus or minus this, is divided by 2a. And when we enter these into the calculator, that's going to make a big difference. So we'll sing it one more time. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There, I'm singing on video. Never thought I'd do that. Hey, an important part of what we're talking about is going to be something called the discriminant. And the discriminant represents b squared minus 4ac. And we want to make sure that we have him isolated because that discriminant is this part of the radical underneath the radical sign. It's called the radicand. And this is our discriminant, and we love the discriminant because it gives us a peekaboo into what kind of solutions we're going to have. If our discriminant is positive, that means that we're going to have two solutions. If it's a perfect square, then our solutions are rational, meaning you can write them as a over b, and it could have been factored. If your discriminant is not a perfect square, then your solutions are going to be irrational, meaning you have a square root that cannot be simplified. If your discriminant value is equal to 0, there is just one solution. And when you think about that, the square root of 0 is 0. So when you have this plus or minus conversation, plus 0 and minus 0 is not going to give you your two answers, just one. If your discriminant is negative, and this is an important consideration, if your discriminant is negative, that means there's no real solutions. That means that you have a negative value underneath your radicand, underneath your radical sign, and when you go to simplify that, you're going to have to end up addressing that negative sign with our plus or minus I. So if we talk about these quadratics, these are what we can affectionately call either our floaters, because they float above the axis, or our sinkers, because they fall below the axis. So they never touch this x-axis. We have them as complex solutions. We know them as imaginary. But we end up saying that there's no real solutions because that imaginary number we had to use. All right, here we go. Let's do one together. If I look at this quadratic equation, my A is 1, my B is 10, and my C is 8. Please make sure you take the time to do this. Write down what each A, B, and C value is, because that's going to help you get everything into the right position in the formula. If I have all my values of x is equal to the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. Let's go ahead and plug in our values. X is equal to the opposite of my b value, which is 10, plus or minus the square root of b squared. Now, I like to just go ahead and square that right away because I know that perfect square and I don't want to get tangled up in anything to do with that exponent. So I'm pretty good at squaring. So typically, I'll go ahead and just b squared minus 4. A has a value of 1. C has a value of 8. All over 2a. So my x is equal to negative 10 plus or minus the square root. Now typically here is where I'll grab my calculator because I'm not going to risk making a silly computation error. So I'm going to go ahead and type what's underneath this radical sign, 100 minus 4 times 1 times 8. And if you notice, I get a value of 68. So when I go ahead and I type that in, I'm going to say 68 all over 2. Now I'm looking at, is this a radical that I can simplify? So I'll have a little conversation over here on the side. So 68, let's break that number down. I don't know, does 4 go in evenly? All right, so that's 4 times 17. This is a perfect square, and I'm done. So I can go ahead and say x is equal to negative 10 plus or minus the square root of 4 is 2. 17 is left behind, and 2. So when I'm solving this, I need to recognize, oh, wait a minute, I have a common factor that can be divided out. So I'm going to divide a 2 out of everything, negative 5, plus or minus the square root of 17. This is my final answer. This is the exact answer. Remember, this 2 divides, it has to be distributed to both. Now, if somebody asks you to round or estimate your answer, you have one more opportunity for feedback, and you can say, okay, somebody might say to you, that doesn't really help me a lot. Can you estimate your answer? Sure, absolutely. So I'm going to grab my calculator again, and I'm going to say negative 5 plus the square root of 17. So that's going to be x is equal to negative point, and we'll go ahead and round to the nearest hundredth, 8, 8, and then negative 5 minus the square root of 17. Keep in mind there's two values there. And my answer here is going to be negative 9.12. Estimated to the nearest hundredth, exact answer. Now let's read what's inside this box. Make sure when you're entering values in the calculator, you follow the order of operations. So if you notice, I did all my work in pieces. I solved for my discriminant, and I worked through. If you try to enter too much into the calculator, make sure that you are remembering this entire expression needs to be divided by 2. So you need to make sure that the entire numerator is divided by 2a. So you won't make mistakes if you break it into pieces. All right, that's page 1. We'll move on to page 2.